welcome to the 2022 Scholarship Calculus. This will be a walkthrough since I have already been exposed to the questions, and I did do the exam this year. To be honest, I didn't do too well. Like most, I only got about half of it, and actually I'll just discuss this after I do it. Okay, let's start. Question 1A. If a is a complex number and absolute value of z plus a is equal to square root of a z absolute value of z plus a, where a is a positive real number and a unequals 1, find the value of absolute value of z in terms of a. So, oops, 1a, so z plus a square root of a. So x plus a whole squared plus y squared, square root of that, is equal to square root of a square root of x plus 1 whole squared plus y squared. We can square both sides. So a squared plus y squared is equal to a x plus 1 whole squared plus y squared, ay squared plus 2ax plus y squared plus is equal to a x squared plus 2ax plus a plus ay squared. Ax squared minus x squared plus ay squared minus y squared is these two cancel out, by the way, is equal to, we flipped everything onto this side, so it should be negative a. Oh wait, oh wait, no, I missed it, like a squared here because of this, because of the squared. So a squared minus a it's x squared no squared brackets a minus 1 plus y squared brackets a minus 1 is equal to a squared minus a minus 1. X squared plus y squared is equal to a squared minus a. X squared plus y squared is equal to a squared minus a over a minus 1, which a squared is equal, which is a because a minus 1, so these two cancels out, so x squared plus y squared is equal to a, and then, so which means absolute value of z or squared is equal to a, so absolute value of z is equal to square root of a. In the exam I forgot to square root the a, so I probably missed a mark there. Question 1b, x plus y equals pi over 4, that's a. 10x plus 10y is equal to 1. But the answer scheme hasn't come out yet, so I'm not entirely sure if these are true, but I'm like I'm pretty confident that my answers are true. So for a, we put it both into, we plug into both 10 pi over 4, so then 10x, actually 10x plus y, they can be expanded into 10x plus 10y, so 1 minus 10x 10y is, in 10 pi over 4 is literally just 1, so 10x plus 10y is equal to 1 minus 10x plus 10x 10y. Mine very hard handwriting. Then 10x plus 10y is literally just 1, so 1 is equal to 1 minus 10x 10y. 10x 10 is equal to 0. I think 10 of pi anything to was it 10? I'm in degrees now, never mind. If I go to it, yeah, anything to the 10 of in pi will be 0. So x is equal to in pi, where in is an element of actually I forgot how to do it. Pop integer. In is an integer which gives and then so then y is equal to pi over 4 minus in pi. So the solutions will be in pi minus in pi, but the 10y can also be 0, so this is the opposite is also possible, so pi over in pi and in pi. These are the general solutions. I forgot to make. Okay, there we go. Question 2. So 10x plus no, question 3. Part C. So x to the power 4 plus x cubed minus 4x squared plus x plus 1 is equal to 0. We can go x to the power 4 plus x cubed plus x plus 1 is equal to 4x squared. We can divide all by x squared, so x squared plus x plus 1 over x plus 1 over x squared is equal to 4. Then we can group it into x plus 1 over x. Actually, to create this, we had to add 2 on both sides. So we had to add 2 here. Plus x plus 1, yeah, because x plus 1 over x all squared is equal to x plus 2 plus 1 over x squared. So we had to add 2, add 2 onto this side and add 2 onto the side, which creates this. You can just make the substitution x plus 1 over x later equal to t squared plus t minus 6 is equal to 0. T plus 3 t is equal to negative 3, but then so x plus 1 over x is equal to negative 3, but x is greater than 0, so x is less than 0, so x plus 1 over x is equal to negative 3. Then if we go x plus 1 over x cubed is equal to x cubed plus 3x plus 3 over x plus 1 over x cubed, which is equal to x cubed plus 1 over x cubed plus 3. And then x which is equal to negative 3 cubed, I think, plus 3 back. X plus 1 over x is equal to negative 27. X cubed plus 1 over x cubed is plus 3 times negative 3, so take away 9 is equal to negative 27. x cubed plus 1 over x cubed is equal to negative 18. I'm pretty sure this. What I did during the exam is I just solved for x and then just plugged in x for this, which that is also plausible. Okay, so question 2a. So consider the equation x squared minus 4x plus 10 new k and x plus 1 all squared where k is real. For what values of k will the equation have two distinct real roots with the same sign? 2a minus 4x plus 10 is equal to kx squared plus 2kx plus k minus 1 or x squared plus gets 2k plus 4 k minus 10 is equal to 0. So sum of roots is equal to negative b over a. So negative 2k take away 4 over k minus 1. If the signs are equal, this has to be greater than 0. So when k is less than 1, then this will always be a negative. Then this k is less than 1. Denom and numerator are both less than 0. Therefore, k is greater than 1 will give so with both positive roots, then right. What did I do for the exam? This is definitely not what. Right. K is greater than 1. Right. Actually, no, I think productive roots is productive roots is c over a, which is prod root is a k minus 10 over k minus 1, which if right. Actually, I think this is a more optimal way. So product was weird. So when k is, I don't think this mattered. I don't think this sum of weights actually mattered. Minus 10. So k is both denom and numerator is greater than 0, or both denom and numerator is less than 0. So if k is less than 1, then both denom and numerator will be negative. Hence creating a positive positive prod of roots when both roots are same sign, prod is always positive. So k minus 10 over k. And the stipulations for both to be positive, for this to be positive, is k is greater than 10 or k is less than 1. But then we cannot create complex solution. We have to create two distinct solutions. So b squared minus 4ac is greater than 0. 2k plus 4k minus 10. Is it k plus 1? K minus 1. (16k plus 16 minus 4k squared) 44k. 40 is greater than 0. 16 minus 44, that is 20, negative 20. These two cancel. K plus 56. No, this is positive. No, this is negative. 60k take away 24 is greater than 0. K is greater than 24 over 60. K is greater than 2 over 5. So k is greater than 2 is, or k is greater than 10. B. Consider triangle ABC. I didn't really find the exact area of the triangle, so I didn't check in this question. This looks better. So 16, 12 alpha, 2 alpha. So using the sign rule opposite. So sine alpha over 12 is equal to sine 2 alpha over 16 using sine rule. Sine alpha over 12 is equal to 2 sine alpha cosine alpha. The sine alpha cancels out. Then this turns into 8. 8 over 12 is equal to cosine alpha, which is equal to 2 over 3. Then cosine alpha is equal to 2 over 3, and if we just inverse cosine that, that gives 0.841, which we cannot just get the exact value. So what we do is we break it into an angle triangle here. So let this be A, let this be B. Cosine alpha is equal to A over 16 equals integration over hypotenuse. So you can just A over 16 is equal to 2 over 3, and A is equal to 32 over 3. So this length here is 30 over 3. This here is 32 over 3. Then we can get this height using Pythagoras, because this is a right angle triangle. So 16 squared minus 32 over 3 all squared, square root of that is equal to height. Let me just get square root of 16 squared minus 30 over 3 all squared. So height is equal to 16 square root of 5 over 3. And we need to also get this base, so maybe I'm going to just break it down to here. So then we can just use SOHCAHTOA again. So 12 squared minus 16 square root of 5, 3 all squared square root of that, which is equal to 4 over 3. So this is 32 over 3, 4 over 3. So the total length of the bottom is, so BC is equal to 9, because 32 plus 4 is 36. So area is equal to half. It's 9 times 16 square root of 5 over 3, which is equal to 8. Wait, no. This is just 24 square root of 5. I believe. Wait, it's 0.5 times 9 times 16 square root of 5 over 3. This is not the answer I got in the exam, and this is also not the answer that suboptimal place got. So I'm just slightly afraid that I might be misleading my viewers. But yeah, the suboptimal got 224 over 9. I mean, this is approximately 53.66. Well, what suboptimal got is 224 square root of 5 over 9, which 224 square root of 5 over 9 is approximately 55.65. I don't know, but yeah, that's what. I mean, this looks more cleaner. My answer looks more cleaner, but I don't know. No, I know. Let's just wait for the marking schedule, I guess. See. So consider a different triangle, which is like just side lengths that form a geometric sequence with a common ratio of r. Well, let's just say this is 1, this is r squared, and this is r. If alpha is the angle opposite to the side that is near the shortest or longest versus the maximum possible of A. So if we do cosine alpha is equal to, actually no, I'm just c squared is equal to a squared plus b squared minus 2ab sine c. Then so r squared is equal to into power 4 plus r minus 2 r squared cosine alpha 2r squared is equal to 2 power 4 minus r squared plus 1 cosine alpha. Then cosine alpha is equal to, cosine of alpha is equal to r squared over 2 minus half plus over 2r negative 2 d cosine alpha over dr. I'm not sure if this is how you're supposed to do it, but I'm hoping. Set d cosine alpha equals 0. So r negative 3 is equal to 0. 1 minus r negative 4 is equal to 0. R minus r is equal to r negative 4. R is equal to 1. Which means cosine alpha equals r squared over 2 minus half plus r to the power negative 2 over 2. R equals 1 gives cosine alpha is equal to half. Alpha is equal to inverse cosine of half, which is equal to pi over 3, I think. Therefore, for max angle is equal to pi over 3 with equilateral. That's what I'm guessing. Okay, if x is equal to e to the 5x, square root of x, e to the square root of x, and the exact value of f dash 0. Let's give natural log of fx. So natural log of e to the 5x times square root of x plus 1 over the square root of x plus 1, which is equal to natural log of e to 5x plus natural log of x plus 1. Take away natural log of e to the square root of x plus 1, which is equal to 5x plus natural log of square root of x plus 1 minus square root of x plus 1. So we derive this d over dx, 5x plus natural log of square root of x 1, take away square root of 5 and with 2 square root of x plus 1. Is this is this true? Natural log of square root of x. Yeah, I'm guessing that's true. Minus which these two cancels out, right? That's weird to think about. Then go that, then that should be correct, I think. Take away so d then so so 5 d over dx natural log 0 is equal to 5. If 0 is equal to, is it 1 times 1 over is equal to e to the negative 1, natural log of f of 0 times f of 0 equal to 5 e to the negative 1. Right, 5 over e and derivative of this function e to the 5x times square root of x plus 1 for 8 is e to the square root of x plus 1 and 0 is indeed, okay, that is quick answer. Coffee filter machine can be used on complex equation. So for this cone, the height, so this is the height, and the height and the diameter is the same, so the radius will be h over 2. dh over dt is equal to dv dt times d dh over dt times d dv times dv over dt. Volume is equal to pi r squared h, pi because h over 2 squared h is equal to cubed over 4. I think this is true. This is h squared dv over d h is equal to 3 pi h over 4 dh over dv is equal to 4 over 3 pi h squared. Then dv over dt is just 50, right? So this is negative 4 over 3. And the depth is 9, so 3 times 9 squared times 50. Let's see, 4 times 50 over 3 is 9 squared times pi. But then, why is it not turning into fraction? 81 times 3, 243. 43 over. Wait, is this true? I got a different answer when I did it. Wait. If I remember quickly, I thought I got a different answer. I thought I got like Newton and pi. Did I go wrong? Pi h over 2 square. Wait, let me just do the second container first. So d v over d dh over dt is equal to h over dv times whole squared h equals volume. Volume is equal to 81 pi h dv over dh is equal to t1 pi dh over dv is equal to 1 over 81 pi. So times 50 is equal to 50 over 81 pi, I think, because dv over dh should be d volume over dt should be 50, so the ratio bigger in the Jupiter, so 51 pi divided by 200 over 2. Negative 3 pi, which suboptimal had like a different answer from this, if I can remember. I got nearly 0.75, but I thought he got. Let me just check it's working. I know this is cheating, but I mean this is just a walkthrough, so I thought suboptimal got a different answer from this. He got a, right, we did. Pi h. So, oh wait, no. Volume is 1/3. So over 12. I don't know. This is just 1 over. 1/3. So this is 12. So this is over 4. No, this changes up. 1/3. Wait, so 1/3. H 1/4. So that's just 4 pi over 81 pi. No, 4 over 81 pi. Wait, this is too different. Right now. So 4. And this is 200. Since 4 over 81 pi times 50 is equal to 281 pi divided by 50 over 81 pi divided by 200, negative 200 over 81 pi, negative 1 over 4. Okay. See the diagram alongside the circle with radius r and center A. Levi's on AC and G on the arc BC. GE intersects chord BC at F. The points E and G move so that the line AG remains parallel to AB at all times. And the maximum length FG in terms of R. Right, it says you need not to put. Right, is this typo always been? I want to check. With my resource sheet in my bag. Is it typo? Is this? You need not prove your solution. You do not need to prove your. It's been a time. You need to not prove your solution is a maximum. See, so we can turn it on its side. Okay. So yeah, we can do it like this. We can cope. So this is r. This is negative. 0, negative r, 0. This line will be y equals x. Then so let this be x. This will be r minus x. This will be x. This distance will be r. So this distance is equal to a right angle triangle. So to get this distance EG, we'll get r squared minus r minus x all squared. Square root of that is equal to EG. This is in the actually this is in the it doesn't matter. This is in the negative quadrant, so I might just edit this negative here, but it might not actually matter. Which is r squared minus r squared plus 2rx minus x squared, which is equal to minus 2rx minus x squared. This is EG, so we also minus x again. So we differentiate. Is equal to length. R is a constant here, I believe, so I think we can just leave it. So length dl over d x is equal to equal to x over square root of 2rx minus x squared minus r. Right. Oh wait, does this negative actually matter? I forgot whether it matters or not. Right, 2r minus x. this. No, but it cancels out. It does not actually matter. Actually, this is the 2x also cancels out. I think so. Minus x r minus x over square root of 2rx minus x squared is equal to 0. Minus x is equal to square root of r 2rx minus x squared r squared minus 2rx plus x squared is equal to 2rx minus x squared. It should be did I go wrong somewhere? Let me check. It feels like I've r squared 2rx minus x squared this should be correct. Oh wait, oh no, wait, 2rx minus x squared, that will give 2r minus 2x over 2rx. Should that be, wait, actually does the negative actually matter? So negative, yeah. Negative. Actually, I don't think negative actually matters. So I'm pretty sure like the 2rx's are supposed to be cancelling out. Is it supposed to be negative 2? I don't. It gives r squared minus 2rx plus x squared, so it should be, yeah, that is plus. Then that is, so this is x, so we take that x away, so you know that this, whether this is a negative or positive sign, it shouldn't matter. I don't think. So 2r minus 2x over 2 over square root of 2x, so these two this cancel out, so r minus x positive is minus 1 minus x us. Is it supposed to be? I don't think. Did I get? I can't tell yet. I went wrong because right, so we solve x in terms of r, so 2x squared minus 2rx is equal to negative. Oh no. Minus 4ix is equal to negative r squared. 2x squared. 4. Wait, this is saying x is equal to r. So, wait. Just seriously. I got a different answer. Like, I think the suboptimal both got a different answer from this, which 2x squared minus 4ix. This is r. Then this is r minus x. Oh wait. Huh? So right, that should be creating a right. I'm not sure if this changes, but this is x and this is me r minus x. This is r minus x. Oh yeah, this would give it like a completely different answer though. Which, oh wait, huh? I don't know. Is it 1? I didn't think it. Wait. 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 Wait, actually, let me just keep that proof in case. So minus r squared. So x squared. Oh no. Oh no, this is just 1 r squared. Oh no. Oh, okay. Wait. And this is so 2x squared minus 1x is equal to negative r squared. X squared minus 2rx is equal to negative r squared over 2. X minus r squared minus r squared. Oh no. 2rx. Oh no, we add r squared to it, so r squared minus root 2 is r squared, which r squared over 2 so r is equal to r over square root of 2. X is equal to, okay, plus r, which is equal to Wait, this, I think, wait. This is quite a this is a different answer from my opinion suboptimal, I think. My friend got big square root of 2 plus 1. But this one is indeed a bigger number, so I don't, if we do it this way, then r squared minus x squared square root of that minus plus x minus r is equal to the length, and then we integrate it, so minus half x over times 2 over square root of r squared minus x squared plus 1 is equal to dl over dx minus x over square root of r squared minus x squared plus 1 equals 0 plus x over square root of r squared minus x squared is equal to 1. X is equal to square root of r squared minus x squared. 2x squared is equal to r squared. Squared is, actually no. No, actually, did I just forget to plug it back into the original one? And so the distance is length is equal to square root of 2rx minus x squared minus x 2 square so minus squared squared cancels out 4 2 I don't know. This is my friend in suboptimal, I think. Do like the 6 squared squared over 2. Actually, no, this is exactly the same. Right. Right. This is exactly the same mostly. Right. Right. Where did my extra plus 1 come from? I don't know. Because squared minus r squared, which gives r squared over 2 square root of gives 2r over square 2 plus r and 2r plus. This seems more of a quick answer. I don't know. Okay, I'm guessing this is the correct way to do it, since this seems better and two people have agreed on it. Okay, question 4a. Okay. Question 4a. This is actually a reuse from like 2015 question 3a, I think. So I'm gonna do it differently. So cosine in theta. Actually, no. Cosine. Cis in theta plus cis negative in theta is equal to cosine in theta plus I sine in theta plus cosine in theta minus I sine in theta. Cancels, so it just gives 2 cosine in theta is equal to e to the I theta plus e to the negative I theta. So so 2 cosine theta all to the power 6 is equal to 64 cosine to the power 6 theta. Then alright, so z plus 1 over z is equal to cosine theta. This is a bit aesthetically, in my opinion. Plus 1 over z tip of n plus 6 is equal to z to the power 6n plus 6 z to the power 4n plus 15 z to the power 2n plus 20 plus 15 z to the power negative 2n plus 20 z to the power plus z to the power negative 4n plus negative 6 inside is z to the power 6n plus 1 over z to the power 6n 6 z to the power 4n plus z plus 4n 15 2n plus 1 over z to the power 2n plus 20 equal to plus 1 over z to the power n to the power 6. We just get n z to the power n plus. Do I just submit? Can I just assume 1? I think z plus 1 is equal to 2 cosine theta. Yeah, I'm just gonna assume 1. Then if we just give 1, if we just get 1, then we get this, where all the n are just invisible. So which is equal to 64 cosine 2 power 6 theta. 64 cosine 2 power 6 theta is equal to 2 cosine 12 6 theta plus 12 cosine 2 power 2 theta. No, this is 2 power 4, so 4 theta. It's 15 cosine. No, not 15. 30 cosine 2 power 2 theta plus 20. And divide it all by 64, so cosine 2 power 6 theta is equal to 1 over 32 cosine 2 power 6 theta plus divided by 4. Yeah, there's 16 cosine 2 power 4 theta. 15 over 2 theta plus 5 over 16. B. Asteroid shown alongside is defined by parametric equation. So if you get cosine 2 power 3 t is equal to x and t is equal to y. If you get x to the power 2 over 3, so y to the power 2 over 3, which is equal to cosine cube t 2 over 3, where the 3 just cancel out. Sine cubed t is just cancelled out, which gives cosine squared t plus sine t is equal to 1. So, which means x power 2 over 3 plus y to the power 2 over 3 is equal to 1. Then y to the power 2 over 3 is equal to 1 minus x to the power 2 over 3. And so y is equal to 1 minus x to the power 2 over 3, or to the power 3 over 2. Then we'll integrate this from 1 to 0, and we want that it will just be here. So we want 4 of them, of 1 minus x to the power 2 over 3 over 2 dx. So when integrating something like a square root function, what makes it, like for example for this, what makes this function very hard to do is this function, this root 3 and this square root. So we want to get rid of those. So to get rid of this outside square root, we can make it into square root of 1 minus cos or sine squared x to the power of 3. So we can make the substitution x is equal to sine to the power of 3 3u. So dx over du is equal to 3 sine squared u cosine u dx is equal to sine squared u cosine u du. So integral and then we have to replace the limit, so x is equal to sine cubed of 1. So alright, so 1 is equal to sine cubed of u, then 1 equals sine u is equal to inverse sine of 1, which is equal to pi over 2, I think. Inverse sine of 1, it is pi over 2. Pi over 2, 0 of 1 minus sine cubed of u all to the power 2 over 3 all to the power 3 over 2 times 3 sine squared u cosine u du. So you can chalk this out to here. So 12 integral from pi over 2, which gives, cancels out, so 1 minus sine squared u by 3 over 2. This is just cosine squared u times sine squared u cosine u. 12th integral of pi over 2 to 0 of cosine squared u 3 over 2, then this just cancel out, so cosine cubed times sine squared u cosine u du. 12th integral from pi over 2 to 0, so sine squared u cosine to the power 4 u du. So we can get 2 out from here, so 3 over 2, 0, so 2 sine u cosine u times 2 sine u cosine u times cosine squared u du, integral that. So sine 2u of cosine u du, integral of that pi over 2 to 0, 3. I think we can just use the form, one of the, maybe it's my formula sheet. Here's my formula sheet. Sine 2u times sine 2u, which gives 3 integral from pi over 2 over sine 2u times sine 2u, half of cosine of 0, cosine of 2u take away 2u, which is just 0, so which is 1. This cosine of 4u times half of cosine times cosine is cosine of 2u plus 1 du. 3 over 4 integral from pi over 2 to 0 of minus cosine 4u cosine 2u plus 1 du. Go from pi over 2, 0. Cosine 2u minus cosine 4u cosine 2u minus cosine 4u plus 1 du, 3 over 4. So cosine 4u times cosine 2u. Of half of cosine 6u plus cosine 2u is cosine 4u plus cosine 2u plus 1 du 3 over 4 integral from pi over 2 to 0. So u cosine 6w over 2. This is negative half, then this is positive 1, so this just, actually let's just ignore that for u. So negative half cosine u 2u plus cosine 2u, so plus cosine u over 2, which is equal to 3 over 4 and actually no, we can just integrate it now. Negative sine 6u over 12 for u over 4 cosine 2u over plus u. No, this is sine. U from pi over 2 to 0. If it's 0, then it will just 0 and pi sine. It's sine pi over 2 0 1. And sine pi over 2 is right, so negative 1 over 12 take. Oh wait, no. Oh, actually, sine 6 u. So all of these just turn into sine. So this is sine 3 pi, this is sine 2 pi, this is sine pi, sine 3 pi, sine 2 pi, sine pi, and sine, any sine of pi is just 0, so all of these just cancels out, which goes 3 over 4 of pi over 2, which is equal to 3 pi over 8. This foci question. Okay, so foci of the ellipse if coordinates negative c0 and c0 respectively p equals 0 and it's an arbitrary point on the ellipse, such as if angle f1p f2 equals 0 is shown, so that the area of triangle f1p f2 is equal to b squared to equate tan theta over 2. So let f to p be distance 1 and the fp to f2 is distance 2. So the area of this would be half d1 d2 sine theta, and the then c squared is equal to a squared plus 3 minus 2ab cosine c, 2c all squared is equal to d1 squared plus squared minus 2d1 d2 cosine of theta. C squared is equal to d1 squared plus d2. But I did this before and I was like struggling so much to do this. D2 cosine theta. This is probably the hardest question in the whole exam. So you got d1 squared plus d2 squared minus 4c squared. Then we can group into d1 d cosine theta is equal to, so we can get this d1 d2 all squared. Then since we added 2 d1 d2 to create this, we have to take away minus d1 d2 minus 4c squared. So 2 d1 d2 cosine theta plus 2 d1 d2 is equal to d1 plus d2 all squared minus 4c squared. By the way, what a foci is like, so here's the major axis. You bring the major axis into like this way, so A gets translated into onto this here, and then you do Pythagoras to figure out the distance it creates between this diagonal major axis and the minor axis. So and then so by that this distance plus this distance and this distance, so distance 1 plus distance 2 is actually just the major axis, two of those major axes, I think. Yeah, that yeah, so yeah, so 2a all squared minus 4c squared is equal to minus 4c squared, and 2 d1 d2 of 1 of cosine theta plus 1 is equal to this, and 2 d1 d2 cosine theta plus 1 is equal to 4a squared minus 4c squared, I think. Where's my formula sheet? They go along somewhere. Wait, huh? 2d1 d2 is equal to 4a squared minus 4c squared over 2 cosine theta plus 1. No, this 2 has just disappeared. Then we can do half b sine c to work out the area. So half times ab is d1 times d2, which is 4a squared minus 4c squared over 2 cosine theta plus 1 times sine of theta. Wait, is this, wait, for ellipse it says foci is a squared minus c squared. Yeah, no, I am correct. Wait. Yeah, I was looking at for hyperbola. Okay, thank God. Okay, thank God I'm correct. So 4 of a squared minus c squared over 4 of sine theta cosine theta plus 1. So cancels out, and this is just b squared sine theta over cosine plus 1. Then we can actually, this is like commonly known to be, this is a common, I mean, it's not too common, but using your formula sheet, I think you can just 2 cosine minus 1 plus 1 cancels, which gives b squared sine theta over 2 over cosine over 2, which is equal to b squared tan theta over 2, which is the answer. Okay. But this is, I made it look easy, but this is like the hardest, that was probably the hardest. Like, if you didn't know what you were doing, that was like extremely hard. Like, it took me like hours to solve that question. Yeah, but anyway. Question 5a. Tan 1 times tan 2 times tan 3 times tan up to 1089 is, so integral of 80 of 10. So the 10 to dot 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 1089 dx. So 1090 minus x, that is equal to 1090 minus 10 all over 1 minus 10. Actually, no, 1090 is impossible, I'm pretty sure. Yeah. Oh no, 10 of pi root 2. Yeah, it is impossible. So we have to break it up into sine 90 minus x, cosine 90 minus x, which gives sine will wait, what's the compound angle for sine? I don't remember the. Just give sine 90 cosine x minus cosine 90 sine x cosine 90 is just 0, so sine 90 over cosine x over cosine 90 cosine x. It's minus, so that turns into plus sine 90 sine x. This is cancels out, so sine, and the sine 90 is just 1, so this we can just ignore those. Which gives cosine x over sine x, which is equal to cot x. So 1090 minus x is equal to cot x. So we can just then so 1 times cot 1 time, which is 90 minus 1, i.e. 89. 10 to cot 2 all the way up to 1044 cot 44. Then it would just be 1045 at the end. And so this go from 8 to 0 dx, so it cancels. This is just 1, so to go from 8 to 0 of 1 dx, which is just a. In the exam, I did like a big oopsie. So the integral of 1 over square root of 1 plus x squared is equal to natural log of square root of 1 plus x squared plus x plus c. To be honest, the easiest thing to do is just differentiate the right hand side, but since I'm at absolute sigma, I will do that. I'll just integrate it. So to get, like I said, the most annoying part of like square root functions and functions is like the square root sign. So we want to get rid of the square root. So a function we can use is 10 squared plus 1 is equal to what's it? 10 squared plus 1 is 16 squared. Yeah. Squared. So dx let x equals to, so that like when integrating, it's kind of weird since like there are occasions where you let x equal to a function of u and u equal to a function of x, so like yeah, be careful with those. X equals 10 of u dx over du is equal to sec squared u dx is equal to sec squared u du 1 over square of 1 plus 10 squared u integral of that 6 squared u du. The square root of 6 squared u integral 6 squared u du. This cancels with this, so 1 over u integral to 6 squared u du. Go of secant u du. Then integrating secant u is like actually a pain. Like, I don't understand how so you have to either know it or like kind of look at the hints. Like, I don't think anyone can come up with it. So what you do is you multiply secant u by secant u plus 10 of u all over secant of u 10 of u du. The sec of u plus 10 of u equal to what's that? V dv over du is equal to derivative of secant u is, wait, I keep on forgetting what it is. Derivative of secant is sec u 10 of u 6 squared u, so dv over secant of u plus 10 of u plus 6 squared u is equal to du. So integral of if you expand this, that's 6 squared u plus sec u 10 of u all over t over d. Oh wait, I know. We made the substitution of v. V is dv over secant squared of u plus 10 of u secant u, which these two nicely cancels out each other. It's integral of 1 over v dv, which is equal to natural log c value of v plus c. Then we made v equal to secant u plus tan u, so natural log of secant u, no, it's not absolute value, 10 of u plus c. Then we made the substitute x equals 10 u. This right, one. Yeah, and then 10 u plus 1 is equal to secant of u, then x 10 squared. Then so 10. So okay, so x is equal to 10 u. 10 squared of u plus 1 is equal to sec squared of u. Sec of u is equal to 10 squared of u plus 1 square root of that, which is equal to square root of x squared plus 1. So natural log of x squared plus 1 square root of that plus x plus c. So that's why but in this case you can just differentiate the right hand side. Last question. How long is it going? Hey, it's like so fast. Let's see. I don't know, like non-exam conditions are like way easier in my opinion. Predators must engage a strategy to catch their prey. When a predator pursues prey, the difference in their speed will influence the path the predator takes in its pursuit. The path y equals fx, Next, I find that one travel to x v1. This question you may assume v1 and v2 are constants. So it's saying make the substitution 2 over dx is equal to a. So d over dx squared is equal to dA dx. So x dA dx is equal to let's do v2 and v equals v1 case. Then that means the constant is just 1. Square root of 1 plus a squared. So 1 square root of 1 plus a squared d is equal to x negative 1 dx. If we just integrate both sides, and we can just use the result from here. So natural log of square root of 1 plus a squared plus a is equal to natural log of x plus c. So if we just then there'll be square root of 1 plus a squared plus a is equal to what's c1 x. Okay, then this is square root of 1 plus squared plus a equal to c1. Alright. No. Oh no. I guess no. That means if dash 1 is just a, so 0 squared 1 square root of that plus 0 c1 of 1 square root of 1 is equal to c, which is equal to 1. So square root of 1 plus a square plus a is equal to x. Is this the end? Right. No, wait, no. How do I continue from here? How am I supposed to do this? Right. Oh wait. Square root of 1 plus a squared x minus a squared plus 1 is equal to square squared minus 2ax plus a squared this cancels. 1 is equal to x squared 2ax. Um, 2a is equal to x minus 1 over x is equal to right, apparently, right. Apparently we consider the concept that lambda is equal to v1 over v2. Actually, I'm a bit more original. I'll let phi is equal to v1 over v2. So phi, integrate that, so which gives phi is still constant. Then each the thing is each the c1 phi x to the power 5 phi. Then I think 1 plus a squared goes c1 x to the 5 minus a o squared plus a squared is equal to c1 squared x to the 2 phi minus 2 c1 x to the phi plus a squared cancels out. 2c1 a c1 squared is 1 over 2 c1 x to the phi. X to the 2 phi c1 squared is equal to a which gives a is equal to half c1 x to the power phi minus over 2c1 x to the power of negative phi. And if a1 is equal to 0, then 0 is equal to half c1 x half c1, right? Alright, there's just 1 minus half c1 c1 squared is equal to 1. c1 is equal to 1. And a is equal to half x phi take away 1 over 2, so negative phi. Okay, and then we gave dy over dx is equal to half x phi, take away x to negative phi. So we can just integrate, we can just, yeah, that it's just dy over dx in a form of this, so which gives y is equal to over 2 phi plus 1 x to the phi plus 1 minus 2 of negative phi plus 1 x to the negative phi plus 1 and plus c if 1 is 0, so right, so 0 is equal to 1 over 2 phi plus 2 minus over negative 2 phi plus 2 c plus 2 is equal to c. Right, what happens? Do I need to give it over 2 phi plus 2 of x to the negative 2 actually I just equate to plus take away 1 over 2 phi take away 2 take away over 2 phi plus 2 is equal to x. Okay, so this is what happens if the constants are different. Then if the constants are not the same, then you can just give one for we just give the constant 1 for we can just substitute phi for 1 squared plus wait that gives wait this gives right actually okay we can just thank God you can just cross those two out, so then minus 1 over 2 phi, so which is equal to 1 over 4x squared minus over 4 this is the equation for this is the equation if this is if they are equal, so if v1 v2 equals v1 then this is the equation, then if v2 unequals v1 then the equation is 1 over 2 phi plus 2 x to the power phi plus 1 take away 1 over 2 phi plus 2 when v2 unequals v1 where equal to v1 over v2. Okay, I believe this concludes the walkthrough. Okay, I usually do a post discussion after each. I've begun doing a post discussion for this. So, I for question 1A, I forgot to list it. So that I took this like I feel it's very easy to think in a non-exam condition rather than an exam condition where you know what you're doing. Like it's like the stress at all. So I perform better at an exam. Like I just read her. Like I've spent a decent amount of time actually solving this outside of school, outside of the exam. So question 1A, I forgot to square it. I forgot to square it this, so I may have gone, may have been got a marks taken away. This one, question 2B, I think I was decent. I'm not entirely sure. C, I just solved for x, then gave the values. So I didn't actually do this. I just solved. I just decided to solve for x and then put x into here. Put x into here. Question 2A. I don't know. I made like weird inequalities for this, so I'm not sure if I'll get full marks. But I indeed did say that these were my requirements for this. Then, oh wait, yeah. For question B, I did not read this. Did not read exact area, so I kind of got muddled up. So I just used cosine rule and used some and rounded it up, so I couldn't find the exact area, which is kind of sad. Then this question, I know I put AR and AR squared and A, which just confused everything. So I know I didn't do that. This question was question 3A was relatively straightforward. Question 3B, I didn't understand what I was saying during the exam, but then I watched Suboptimal Place live stream and it was quite straightforward. Then question 3C, I found this extremely difficult. Like I wasn't able to think of it during the exam, but I mean, after someone said, "Oh, you can just turn it on its side and put it in a Cartesian plane," like this is not really a Cartesian plane, but you can just put it in a Cartesian plane like this, then it is relatively more straightforward. But I'm not sure if what answer is correct. I know. Yeah, question 4A was quite. It was a read. Like it probably was quite hard for most people. I'm not sure. Like I have heard some people say it's easy, but for me it was extremely easy since it was like a 2015. It's like a reuse from 2015, so it's relatively straightforward. Question 4B, I wasn't able to do it during the exam, but yeah, after I discussed with my teacher, he just told me make a sine cubed substitution, which kind of made it more straightforward. And I was able to solve it. And question 3C, like I spent like 2 hours on this before making this video, so it was like really I struggled so much with this, and so I mean, like looking at this now, it is relatively straightforward, but it was so difficult during the exams. There was like it felt like there was so many ways you can approach this question. Question 5A. I don't know why. Okay, I show what I did. I'm not sure if anyone is interested, but I turned it into sine 1, sine 1 sine 44, sine 2, right, so this is brackets, this is sine 2 sine 45, and a sine 1 45, sine 2 46, sine 3 sine 47 dot 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 all over cosine 1 cosine 45 cosine 2 cosine 46 dot dot dot. Then I looked at my formula sheet and I saw that sine 45 times sine 1 is half of 1 minus half of cosine 44 minus cosine 46, half cosine of 44 minus cosine of 47, and 48, half cosine of 44 minus cosine of 50 dot 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 all over. Then I looked at cosine, which turns out to be half of cosine 46 plus, right, no, that sine is minus half cosine 46 plus, oh wait, I thought this is cosine minus sine 44, so then half of cosine 47 minus cosine 44 dot dot dot. So I just thought it was just -1, but it turned out I read it incorrectly. So apparently it's supposed to be plus instead. So with me, question 5b, I differentiated the right hand side, but x squared plus x c d over dx of that. I had to do it like x dx is equal to x over square root of 1 plus x squared plus 1, then dy over du is equal to 1 over square root of 1 plus x squared plus 1 over square root of x, 1 over square root of 1 plus x squared plus x. So 1 over square root of x squared plus x over 8 times square root of 1 plus x squared plus 1. Then I made it like this, so square root of plus x squared plus x over x plus 1 plus x squared over square root of 1 plus x squared, then x plus square root of 1 plus x squared all over 1 plus x squared plus x square root of 1 plus x squared. Then I wasn't sure, but then I thought of something like x plus square root of 1 plus x all squared, group them together, which is x squared plus 2x squared of plus x squared plus x squared. So to get and then to group this is x plus square root of 1 plus x squared over x plus square root of 1 plus x squared all squared minus x squared minus x square root of 1 plus x squared. Right. Then, right, is it? What did I do? Then x plus x squared x plus square root of 1 plus squared minus x. Yeah, actually this is just minus x. So 1 plus square root of 1 plus x squared. So minus x. This is just this. So then we just cross these out. So 1 over plus square root of 1 plus x squared is x, which is equal to 1 over square 1 plus x squared, which I know, I felt like a giga chad when I did this. But I think there was like a way easier way to do it or something. Then question 3, see, I was also really confused on on how to do it. Like, yeah, differential equations is my weak point, so yeah, this is very confusing. Okay. Yeah, so I think I've solved everything. Okay. Thank you for watching and goodbye.